Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy, and today we're going to follow up on last week's talk about underfloor air distribution with a discussion on perimeter systems for underfloor air distribution. So just like any other HVAC system, the perimeter of a UFAD system has to be handled separately from the core. In the core of the building, the loads are fairly consistent and can be handled well with the swirl diffusers that we discussed last week. As underfloor air distribution gained popularity in the late 90s, the perimeter was usually handled with a fan-powered VAV box, like a standard overhead system. It would look something like this. So let's draw in the raised floor, some swirl diffusers. At the perimeter, you would have a fan box ducted to a slot diffuser, just like you would in an overhead system. This meant that you had to have a ceiling plenum and ductwork in the ceiling, and that could add height and ductwork and VAV boxes to the building, so it wasn't an ideal solution. So we started making fan-powered boxes that could fit under the floor. The challenge here is that the box needs to fit within the 2x2 pedestal grid so that you don't have to span over boxes. First, we developed the LHK, which is a long, skinny series fan-powered box that you could get electric heat or hot water reheat on. It looks something like this, where you've got the damper, some control boxes here, the fan, here's your electric reheat. Then you would duct it to a linear bar diffuser. Because the supply inlet and the induced air inlet were in the same plenum space, we were often asked to cap off the induced air inlet unless the engineer wanted to duct it to the return air. Since we were often capping off the induced air inlet, it just made sense to pull the air from the pressurized floor through the fan and then duct it into the space. Let's move this out of the way a little bit. So next we made the PFC. That looks something like this. It's a booster fan box. You have the inlets on this side, the fan, electric heat. Again, it's ducted to linear bar grills, and then it would just pull air in from the inlets through the fan and then up into the space. Now ideally, you'd want to get rid of the fan boxes altogether, but the challenge is, how do you handle the higher loads of the perimeter? Another challenge that I haven't mentioned is that both the overhead fan box system and the underfloor fan boxes ducted to the linear bar grills break through the stratification layer that I discussed in the last podcast. So let's draw a side view of these systems. The overhead fan box will have a throw that looks something like this. Now let me draw a side view of the underfloor system with the fan-powered terminals in the floor. And the linear bar grills will have a throw that looks something like this. Both of these will mix warm ceiling air into the occupied zone, which you're trying to avoid with your underfloor system. That's where our TAF-L perimeter system came in. The TAF-L system has modular heating and cooling plenums that use no additional fans and have a specially designed linear bar grill to keep the throws short. The cooling plenum, the TAF-LV, uses the pressurized air under the raised floor to supply the perimeter with cooling. Okay, so let me draw a side view of this. If this is your perimeter wall and there's your floor, what you have is kind of an angle frame mounted on the perimeter, and then your pedestal starts in here. The TAF-L system sits between these two, which is kind of nice because then you don't have to cut the floor tile to get the perimeter system in. So this is the TAF-LV, which sits on the angle in the floor tile, and then the CT TAF-L grill sits on top. It kind of looks like this. So down here there is a damper. It's a sliding damper and an aperture plate. So as the damper slides across the aperture plate, it opens and closes the slots of the aperture plate, and it allows air to come through, and it varies the volume of it. As the air comes through the grill, the deflection actually changes as it moves away from the perimeter wall, and so you get a spread of the air pattern like this. Let me move this out of the way a little bit now so I can show you a video of it in action. Okay, let me bring the video in, and we'll put it right here. So what you see here is our cold wall and our raised floor. The air is coming out of the raised floor, and it's enough airflow to handle the cold wall. I think this is about 225 CFM in a 4-foot section. And you can see that although it's using a linear bar grill, it has a fairly short throw. Okay, so now let's talk about the heating side. The heating unit comes in a hot water or electric heat called the TAF-LW or TAF-LE respectively, and uses the natural convection currents to heat the perimeter. So again, let's draw this out in a side view. So again, this is our perimeter wall and our floor. Again, you have the angle frame and the pedestal where the raised floor starts. The TAF-LW or E will sit in here just like the TAF-LV. Then there's a divider in the middle, and the reheat coil sits towards the perimeter wall. Just like the TAF-LV, the grill sits on top. Let's draw that in. Now the way this works, the cold air will fall off the perimeter glass. That will induce room air into the front, and everything will fall to the bottom of the plenum. Now the reheat coil is down here, so as the air passes over it, the air will warm up and rise. And that's how you would handle the perimeter heating. So now let's bring in a video of a test we did with the TAF-L heating unit. So what you're looking at here is a close-up of the unit without the grill. You can't really see the air fall off the glass, but you can see the room air is actually being induced into the unit, and it falls into the plenum and rises up the backside along the glass. So remember, there's no fan being used here. So how you would use this is that you would alternate cooling and heating units across the perimeter. So it'd look kind of like this, with maybe a heating unit, a cooling unit, a heating unit, and a cooling unit. Or maybe it's just 2 heating units and 1 cooling unit, depending on your load. But the CT would be continuous across the top, so it would look from the room to be one continuous grill. The TAF-L system has addressed the perimeter heating challenge in a way that doesn't add fan boxes and doesn't break the stratification layer. So that covers the different ways of handling UFAD perimeter systems. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.